Hello everyone. In this lecture we'll cover a very important topic for CAT, that's successive percentages. It is a very important concept and it will help you a lot to solve compound interest type questions and certain multiplications for DI. It will be very helpful in DIs as well as in compound interest type questions. Now what is successive percentages? Suppose 100, there's an increment of 10%, it becomes 110. Then again there's an increment of 10%, it becomes 121. Now this is what is known as successive percentages, successive increase. Now how do you calculate? What is the overall increase? 21%, right? So now how do we get this 21%? 21% is nothing but 10, this is the first, this is A, this is suppose B, then A percent, B percent. This is 10 plus 10 plus 10 into 10 by 100. That is A plus B plus A into B by 100. Right? This is how you get 21. So in this type of successive percentages, suppose in DIs if you get there's a increment of 10% in profit every year. So this is how you actually go about calculating the final percentage by using this formula. Now let's see the uses of this thing. It's very useful. First I'll show you an example. Suppose you have to calculate 11 square. What is 11 square? 11 square is 121, right? Now how do we see it as successive percentages question? You can write it as 11 into 11. That means on 10 there's an increment of 10%. Then again there's an increment of 10%, right? We can see this question as two consecutive times we are increasing 10% on 10, right? So it can be written as 10 into 1.1 plus 10 into 10 into 1.1, right? What two times consecutively if you increase 10%, we have seen that the overall increase is 21%. There's a 10 into 10, 100, and then a 21% increase, that is 121. Right? So I'm not saying that you have to do a square by using this, but we'll see how we can use these things. Okay. Now suppose you have to calculate 1.02 to the power 4. Right? Now it's very lengthy to actually calculate 1.02 to the power 4. Now you can see it as a 2% increment on 1. Right? So there's a 2% increment 4 times. Right, to the power 4. So we have a 2% increment 4 times. What is the equivalent of 2 into 2 plus 2 into 2 by 100? That is 4.04. You can approximate it to be 4. Okay. Again 4. Now 4 and 4 is 4 plus 16 by 100. 8.16. Right. Now 8.16% of 1 is 0.0816. So what is the value? 1.0816 approximately. It would be a little bit more than 1.0816, but you can approximate it to be 1.0816 because it won't matter if this is even a 17 or 18 because it's the fourth digit after decimal. So approximately you can say it's 1.0816, right? Now suppose you have to calculate 1.03 to the power 8. Now it's very difficult to calculate it directly, right? But you can, as a successive percentage, you can say 3% increment 8 times, right? Now you can approximate it to be, it's a 6.09, you can approximate it to be 6, okay? 6 and 6 is 12.36. Say suppose you take it as to be 12 itself, it's 12.3, but if you approximate it you can say it's 12, and 12 and 12 is 24, 12 plus 12, 24 plus 144 by 100, so that is 25.44, right? So 25.44 percentage of 1 is 1.2544. This is the approximate value. It is a little bit more than this because we have approximated it, it should be 12.3, and then you will get maybe around 26 to 1.26 or something. But this is how you can approximate and use successive percentage. It is very useful in compound interest type questions and DI. Suppose you have to calculate 1.2 into 1.3 into 1.4 into 1.5. Now, if you have to calculate this, it is going to take a lot of time. But instead, you can look at it as a 20% increment, 30%, 40%, and a 50%, right? 20 and 30 is 50 plus 6, 56. 40 and 50 is 110. Now, what is the equivalent of this? 166 plus 56 into 110 by 100. You can write it as 56 into 1.1. You can approximately say it is 56.5. So this will add up to be 222.5. A percentage of 1. Therefore, the final answer will be 3.225. Right? So this is how you can calculate it. This, instead of going about for a long method, you can easily say that it is going to be around 3.2, right? This is how you can do these types of questions for both DI as well as for compound interest type questions. Now suppose there is a question on compound interest. The principal is 500. It is given that the rate is 10% and the time period is 2 years compounded half yearly. Okay, so what is the amount? Now the amount will actually be 500 into, since it is half yearly, it will be 1 plus 5 by 100 to the power 4. This is 10% per annum. Okay, so if you actually have to calculate it, it becomes very difficult. It is 500 into 1.05 to the power 4. Now to calculate 1.05 to the power 4 is lengthy. Suppose it's 4 years, that will be 8. So it will take a lot of lengthy calculations to actually do it. But instead, if you use successive percentage technique, you can directly write this as approximately 10.25, this will be 21. So it should be greater than 21. It would be greater than 21.5 in fact. So you can write this as 500 into 1.21. Suppose it's 121 by 100. It is 605. It should be always greater than 605. A little bit greater than 605 because we have approximated this. It should be 10.25, but we have approximately taken it to be 10 and we have got 21. If we don't approximate, we will get 21.5 something. It won't have a huge impact, it will be point something, right? So it will be a little bit more than 605. So instead of calculating 1.05 into 1.05 4 times, we have used successive percentages and we have made this problem very simple, right? Suppose the same type of question. It's given it's 700, say 12% for, now this time let's increase the time. It's 3 years and compounded quarterly. So what is it? 700 into 1 plus 3 by 100 to the power 12. Okay. Now this you can, instead of 1.03 12 times, you can say write it as 3 is 12 times. If you club 2, you can say 6 is 6 times, right? Approximately 6. You can say 12 is 3 times, right? Now if you take 12, 12 and 12, this is 25.4. You can approximately say it's 25 and 25 and 12. So 25 and 12 will be 37 plus something, 37 plus 25 into 12 is 300 plus 3 is 40. So 40% is the final total. You can say it's 700 into 1.4. Right? So instead of calculating 1.03 to the power 12, we have used successive percentage and we have reduced the calculation drastically. Now you do not need to worry about calculating it. We have just simply done it in maybe 15 to 20 seconds by approximating it and using the concept of successive percentages. Any type of questions for compound interest, you can approximate and find the percentage very quickly. Right? Now, even in case, now since we have considered only the even factors, now if you have to calculate 1.03 to the power say 5, you can say 3, 3, 3, 3 and 3 5 times. This you can say 6, this you can say 6, and then you can take 3 separately, and then again you can calculate you using the same techniques. You can club these two or you can club these two. It's not a problem, and then you can finally get the overall percentage. Okay. This is how you can reduce the time and very easily calculate such complex questions. Suppose there is a question, compound interest taken for 2 years and simple interest taken for 2 years. The difference is 12 rupees. Okay, and the rate is given to be 20%. So what is the per annum? What is the principal amount? If the difference between compound interest and simple interest for 2 years is 12 with 20% rate per annum, what is the principal? Now, since it's 2 year, we can say 20 and 20. What is the final percentage? 44. For simple interest, it's simply 20 plus 20, 40. So the difference is 4%. Now you know, if it is 100, if P is 100, the difference is 4 rupees. Since we have a 12 rupee, we know that principal should be 300. So you need not calculate anything. Simply using the concept of successive percentage, we have calculated P easily, right? Suppose a similar sort of question is there, key compound interest for 3 years and simple interest for 3 years. The difference is 62. Okay. Now, and the rate is given to be 10%. So what is the principal, right? So again, you can approximately, you can calculate, this is 10 and 10 is 21. 21 and 10 is 31 plus 2.1. So it's 33.1, right? And for simple interest, it will be simply 10 3 times, that is 30. So what is the difference? 3.1%. Now, for 100, there is a 3.1 rupees, right? And we know that it's 62. So for 62, it will be 2000 rupees. The principal is 2000 rupees, right? So very easily, by using successive percentages, we have calculated this question, and we have solved this question in a matter of seconds. In fact, we have solved all those compound interest questions, which actually would have taken you a lot of time, because you had calculations like 1.03 to the power 8 or 1.02 to the power 12. All these things you can calculate very easily simply by using the concept of successive percentages. So it's a very important concept. Please practice it and gain confidence. You will save a lot of time in solving compound interest and simple interest type of questions, as well as in this DI, wherein we took an example of 1.2 into 1.3 into 1.4 into 1.5. If you have any such types of calculations in DI, you can easily use the concept of successive percentages, wherein in questions like it's given that there is an increment of 10% in profit in the first year, then 20 in the third, second, and maybe 25 in the third. You can use concepts of successive percentages and solve these questions very quickly. You can save a lot of time in this. So it's a very important concept. Please go through it and tune into Collegepedia.in for more lectures. Thank you.